Hello everyone, welcome to our presentation. Today I will be talking about our demo, which is about using federated learning along with graph neural networks for anomaly detection. So here is our scenario. So basically our goal is to use federated learning for improving a graph neural network based intrusion detection system in a multi-node cluster. And along with that, we also would like to integrate an MLOps tool called MLflow for tracking our results and for better visualization of our metrics. And the scenario is as follows. So assume that there are 5 nodes in our cluster, each of which has its own local dataset, which contains sensitive information regarding the network packets passing through the node. And among the nodes, across the nodes, there is a class imbalance dataset, so that the ratio of attack types or benign data is different in each node. So in this scenario, we would like to use federated learning to create a more accurate global graph neural network GNN based model that would be used by all of the nodes for intrusion detection. And here are the steps for our demo. So first of all, we are going to start the federated learning pipeline with 10 runs, and during the process we are going to choose 3 clients out of 5 in each round for training. As round goes on, we are going to see how our performance metrics vary or improve across the rounds using MLflow UI, which is our MLOps tool. And after the federated learning process is over, we are going to compare our results with the traditional approach where each node trains a separate individual model using their own local dataset, and then we are going to compare the results of this with our federated learning model. So let's get started. So first of all, let's start with the MLflow server. Then we are going to spin up our federated learning components. By the way, we are using the Flower framework, so you can also check its documentation for how it works, the architecture. So basically those are all Flower related commands that I'm executing right now. Okay, so finally let's start our federated learning task. Here we are going to be running like a 10 round federated learning setup, and we are going to be seeing how the metrics will change using MLflow UI. So for the rest of the video, I'm going to speed up. So this will take a while, but you are going to see that it's gonna take less because I will be speeding up the video. So see you in a few seconds. Hello everyone, welcome to our presentation. Today I will be talking about our demo, which is about using federated learning along with graph neural networks for anomaly detection. So here is our scenario. So basically our goal is to use federated learning for improving a graph neural network based intrusion detection. Alright, it looks like our federated learning process is now completed, and you can see how the performance metrics change across rounds. Different performance metrics like F1 score, precision, and recall. So yeah, and let's check our MLflow UI for better tracking of our results. So if you go here, you can see our model metrics and see how they are changed. So for instance, you can see the training recall going from 97% to 99%, and also the change in validation loss or recall accuracy. There's lots of parameters where you can actually check. And you can see the total emission, something called total emission, which is about the carbon emission of our federated learning process. However, as you can see, it's all zero now, which I'm going to mention in the next phase. So just know that there is also a feature like that, but it's not used now, but that will come up later. So okay, let's start now with our individual setup. So since we are already have the global model constructed from federated learning, now we are going to have the individual models. And for that, I'm just going to run this file. Yeah, so for the local model training, I'm just going to run this file and train the models. So let's see. So again, this will take a while, but in order to save you from time, I'm just going to speed this up and let you know once it's done. Okay, it looks like it's the individual model training is also completed. So now we can actually compare our results. So for that, we are just going to go here and open this in Finder and check the confusion metrics. And you can see that for individual workers such as 0 or number 3 or number 4, there are some issues with some of the classes. Some of the classes have lower accuracy, as you can see, but with the federated learning setup we have higher accuracy for almost all of the classes. As you can see, it's all 95+%. So this actually shows how federated learning can improve the global detection by using collaborative training. Okay, and apart from that, there's also next steps. As you can remember, I've mentioned something about the emission, carbon emission, and this is our actual next step because we are planning to integrate an actually carbon tracking tool, which is going to be called Carbon, to estimate the carbon emission of each client and try to come up with some carbon aware client selection which would make the federated learning process more sustainable. So that will be our next step, hopefully. And thank you for your attention. And if you have any questions, please don't hesitate to ask.